This call is now being recorded.
So as you can see from my screen, the topic we are looking into is going to be simultaneous equations. That is what you are going to look into this morning. I believe you are all aware of what simultaneous equation is all about from what you have done in your junior class. So basically, simultaneous equation are those equations where we have two unknown. The kind of equation where we have two unknown, and those two unknown are to be solved together. That is what we refer to as simultaneous equation. Is that clear?
Yes.
Can I move on?
Yes.
Yes, sir.
The kind of equation where we have two unknowns. So let's look into it. Please, name out. Can you please mute your mic there? I think there's a background noise. So let's look into this. So introduction. So simultaneous equation, as you can see from my screen, is basically these are the equation where we have two or more unknown, and we tend to find the value of the two unknown together. Is that clear?
Yes.
So it is the kind of what we have two or more equations with two or more unknowns. You understand? Two or more equations with two or more unknowns, whereby we tend to solve the two unknown together. We have two unknown, probably we have x and y, or we have x, y, z, and we tend to find the value of that x, y, z at the same time. So that is what we call a simultaneous equation. Some people say simultaneous equation, but to me it's not important. So when you say, I did the work simultaneously, meaning you are doing them concurrently, you are doing them together. That's the meaning of the term simultaneous. So, and there are two formats of simultaneous equation. You understand that now? There are two formats of simultaneous equation. The first one we have is purely linear simultaneous equation. Are you getting my point?
Yes, sir.
Yes.
Now, so we have purely linear simultaneous equation. It's possible they won't classify like this for you, maybe at school, but just to let you know that we have two formats of simultaneous equation. That's why I'm stating this. We have purely linear simultaneous equation. The meaning of purely linear simultaneous equation, there are those simultaneous equation in which there's nothing like square term in the simultaneous equations. Meaning we don't have anything like x squared, nothing like y squared there. Such kind of equation are referred to as what? Linear simultaneous equation or purely linear simultaneous equation. Are you getting my point? Like the example of what I'm having here. I'm having ax1. If you look at ax rather, I have a1x. If you look at the value of x I'm having in this place, the power of x in this place is just 1. Nothing like x squared, nothing like y squared from the terms I'm having in this place. We have x and y, we have x and y, x and y. That is the first thing you need to check. So it shows that it is linear. The second thing is that we don't have any equation among the two equations whereby we have x and y multiplying each other. We don't have anything like xy in our expression. So if there's xy there, there's probability that your solution will lead to a quadratic equation. So what you have, if you have a condition whereby the power of x and y or the power of unknown there are just what? 1. The power of unknowns are what? Are 1. In that case, we refer to as what? Simultaneous equation or simultaneous linear equation. Simultaneous linear equation. If there's nothing like quadratic term, nothing like square term or cube term in the expression, we call it simultaneous linear equation. Note that A1, B1, A2, B2 I'm having here, they are all constant. And C1 and C2, they are all what? They are all constant. Is that taking? They are all constant based on what you have in this place. Meaning they are just purely number. So that is what you need to get right. So for purely linear simultaneous equation, the maximum power of unknown is 1. And there's nothing like multiplication of unknown together based on what you have there. Can I move on?
Yes, sir.
Now, so let's move on to the next part. So the second type of simultaneous equation we have is one linear, one quadratic. The second one we have is one linear, one quadratic. So for one linear, one quadratic, if you look at the first equation I'm having in this place, ax plus by equals to c. The first one I'm having there is purely linear because there's nothing like square term there, and x and y are not multiplied together. They are not multiplied by each other. Do you get that? Is that clear? Can I move on?
Yes. Sir, can you repeat it again?
Now, I said if you look at the first equation here, if we check the first equation I'm having in this place, it is purely linear equation. Let me use a red color. The first one I'm having here is linear. The equation 1 is linear because the power of x is 1. The power of y is also 1. And x and y are not multiplied together. So it is linear equation. And the second equation, which is our equation 2, is quadratic. If you look at it, we have x squared, then we have y squared in our expression. So this type of simultaneous equation, whereby we have square term, it is what we call simultaneous linear quadratic equation. Simultaneous linear quadratic equation, or in some textbook, they will call it one linear, one quadratic. So these are the two formats of simultaneous equation that we have. So what we are going to center our attention on first is going to be one purely linear simultaneous equation. We are going to focus on this one first. The one where we'll have the value of x and y being the power of them are equals to 1. Don't worry, all this one are just long English. By the time we start solving now, I believe you understand them better. But just know basically, if you see equation of the format x and y are not multiplied together, and we don't have anything like square term in the simultaneous equation, it is simultaneous linear equations. Simultaneous linear equation. If there's no square term and x and y are not multiplied together, it's called simultaneous linear equation. I hope that point is clear to us, please.
Yes. Yes, sir.
Now, then the second one, once you see square term in the simultaneous equation, or you have x and y multiplied by each other, if there is square term and we have x and y multiplied by each other, in that case, we have one linear, then one quadratic. And the method you are going to use in solving this one will be different from the other one. This one will lead to quadratic equation, while the linear will not lead to quadratic equation. Can I move on?
Yes. Yes.
No. So let's move on to the next page. So what are the methods of solving simultaneous equation? Sorry, I think there's a typo error here. Have one. What are the methods of solving simultaneous equations? Let me quickly correct this. What are the methods of solving simultaneous equations? So we have varieties of methods of solving a simultaneous equation, as you can see from my screen. We have different methods of solving simultaneous equation. The first one of them is what we call elimination method. From what we have done in junior class, we have elimination method, we have substitution method, we have graphical method. Then I believe you haven't done this one, Cramer's rule. Then we have inverse matrix method, we have Jacobi iterative method, we have Gaussian method, plenty method of solving it. You understand? However, for your level, for what you are going to do in the class now, if time permits me, we are going to look into elimination method of one. We are going to look into elimination method. We'll look into substitution method. We will look into possibly, I'm not so sure of that, Cramer's rule. I'm doing that with SS3 currently. That is the street of Uganda matrix and determinant. Likewise, inverse method will be done with SS3 as well. So if you're interested in that, there's a video in the group, in the folder that I sent there. You can learn that method. It's very simple, even compared to other methods that we'll have. So we are going to start with elimination method. Now, note something here. Let us note something here. Substitution method can be used for any question. Is that taken? Substitution method can be used for any question. Whether linear or quadratic, you can use substitution method. However, elimination method can only be relevant when you are dealing with simultaneous linear equations. Take note of that. Elimination method can only be used for simultaneous linear equation. Is that taken?
Yes. Yes.
So the elimination method can only be used for simultaneous linear equation. So that is what you need to take note as far as this one is concerned. Can I move on?
Yes.
No. So let's look into this now. So we are going to start with simultaneous linear. You can solve simultaneous linear equation using elimination method. Solving simultaneous linear equation using elimination method. Are we good to go?
Yes, sir.
Now, so let's start now.
Yes.
Now. So let's look at the first question we are required to solve these equations. We are required to solve this equation. Solve the equation 2x plus y equals to 10 and 3x minus y is equals to 5. 2x plus y equals to 10, then 3x minus y is equals to 5. Now, There are some fun. I know some of you will know how to solve this. Is anyone of you that know how to solve this or that can solve this one directly? Anybody? Nobody? Don't be shy. You can let us know.
Yes.
Now?
Yes, I can.
Supposed to collect.
You're supposed to collect the like term. That is if you want to use the elimination substitution method. Now, Nima, which method are you going to use if you have to solve it?
Substitution method.
Substitution method. I don't want us. We are dealing with the elimination method now, so we need to know the two methods. Because in the exam they can specify or be specific about it that using this particular method. So it's very simple. The method we are going to adopt now is very simple. So can we move on? Have you written the question?
Yes.
No. So
Yes.
So and then if possible you can be solving along the line with me to make it easy. Now, if you want to use the elimination method, your first goal is to ensure that in equation 1 and equation 2, it is either x in the two equations will have the same coefficient, or y in the two equations will have the same coefficient. That is the major goal you always focus on. Is that taken?
Yes.
Goal 1 is what? Ensure the x are having the same coefficient, or you ensure the y are having the same coefficient. So if you're given a question whereby you have the value of y are sharing the same coefficient, that is the simplest of all. Or the value of x are having the same coefficient directly. That is very simple to do. Like in this case now, what is the coefficient of y in equation 1? Everybody.
1.
1.
Plus y.
Plus y. No, there's a number there. How many y am I having there? 1. Thank you. So let us leave the sign. 1. So let us leave the sign for now. Let's focus on the number. That should be the first goal. What of the second equation? What's the coefficient of y?
1.
Minus 1. Okay, I agree with you. Minus 1. So both of them are 1, 1 if you observe it. So since the coefficients are equal, then the problem is very, very easy for us to do. Very, very easy for us to do. Now, let's take down the following rules. Take down the following rules. Take down the following rules. When you are solving simultaneous equation, the first step I ask you to do is to check whether the coefficients are equal. If the coefficients are not equal, you make them equal. That's the first step. The second step is if the signs for those letters whose coefficients are equal are the same thing. Let me say it again. If the signs for those letters whose coefficients are equal are the same sign, meaning if you have plus plus or you have minus minus for the letters whose coefficients are equal, in that case, you will subtract. You subtract the equation from each other.
Sir, please can you repeat it?
Let me say it again. If the signs for the letters, whose coefficients are equal, if the signs for the letters whose coefficients are equal. Can I move on?
Yes, sir.
If the sign for the letters whose coefficients are equal are the same thing. By that I mean if they are plus plus or they are minus minus. In that case, we subtract the equation from each other. Is that taken?
You subtract
the equation from each other. You subtract the equations from each other. Is that clear enough?
Yes, sir. Yes.
Now the second one, if it is opposite now, don't let us repeat the grammar. If the signs are different now, then you will add. Meaning in that case, if you have plus minus or minus plus, in that case, you are going to add the equations together. I hope that is clear to an extent.
Yes, sir. Yes.
Now, so take note. This is the fundamental rule. This is what we are going to be playing around. You understand? This is what we are going to play around. And for you to remember, same sign subtract. You know, we have something called SSS, right?
Yes, sir.
SSS, that is State Security Service. So same sign subtract. That's the meaning of my own SSS there. Same sign, Same sign subtract. Just take note of that. So if you have different sign now, you will add. So, but if you know same sign subtract, opposite is going to be the way for the other one. But remember, the first step is what? You will first check whether the coefficients are equal or not. If the coefficients are not equal, you make them equal. The second step is now going to be subtraction, then substitution. So let's move on now. Can I continue now?
Yes, sir.
No. So let's check this equation now. The first check that I ask us to do is what? Check whether the coefficients are equal or not. Are the coefficient of x equal in this equation? For equation 1 and 2, are they equal?
No.
Everybody, please.
True.
Now, Mariam,
No.
Jafar.
No.
No. So coefficient of x are not equal. But let us check for y before we conclude. Are the coefficient of y equal in this time around? Now,
Yes.
everybody, please. I want everybody so that I know everybody is moving, please.
No.
Okay, that's why I want us to actually say everybody should know.
Yes.
The coefficient, okay, it's 1, 1. Forget about the sign there. They are both 1 and 1 for y, right? They are the same thing. Now, check the sign that you are having. The first step is to check whether the number are equal. Now, check the sign that we are having. The sign we have in this place, are they the same sign or different sign?
Different.
Some of you are not talking, and I'm not pleased with that, please. Are we having the same sign
Different
for y or different signs for y?
Different.
Different signs for y. Now, so if you're having different sign, what are we going to do based on what I mentioned earlier?
You're going to
Add.
We are going to have. So that's going to be our next step now. So from what you have seen, the signs that we have in this place are not the same thing. You are going to add equation 1 and 2 now. You can say I put plus there now. We had equation 1 and 2. Can I move on?
Yes. Yes.
Yes.
Yes.
So to add equation 1 and 2, let's add the equation of 2x plus 3x. What will it give me?
5x.
That will give me 5x. That is 1. Now let us move to the second side now. Plus y, since the two of them are sharing the same coefficient, don't need to disturb yourself over this. Plus y plus minus y. That will give us 0. Automatically to give us 0. Plus y plus minus y. That will give us 0 automatically because they share the same coefficient. And that will be equals to go to the last side now. 10 plus 5. That will give us what? That will give us 15.
15.
So from this, I'm going to have 5x now to be equal to 15. Divided by 5. Divided by 5. 5 and 5 we can now to be equal to 15 divided by 5 will give us 3. And we are done with the value of x. Are we getting the point, please?
Exactly.
Yes.
Everybody, others, are we getting the steps?
Yes, sir.
Now, so that's going to be our first step here. Then, since we have gotten the value of x now, the next step is now going to be substitute. You can say put or substitute, anyone you like. Let me use one of the easier so that will not cause confusion. You can use substitute, you can use put. I'll prefer to use put so that you don't get confused. Okay, Usman, you say you can't see my screen. Is it everybody that cannot see my screen?
No.
Okay, Usman, I think it's your network. I think it's your network. Now, the next step is after you have gotten the value of x now, we can now say put or substitute, anyone you prefer. Put x equals to 5 in either of the two equations, any equation you prefer out of 1 and 2.
Equals to
Now?
3. Equals to 3.
Okay,
X equals
thank
to
you so
3.
much. Thank you. Put x equals to 3, right? In equation what now?
Yes.
In equation 1. You can use equation 1, you can use equation 2. Anyone you use, either of the two give you the same result. In equation 1, first write the formula there down. That is 2x plus y is equals to 10. That will be your first step. The second step is now going to be 2 into bracket of 3, close the bracket, plus y is equals to 10. 2 times 3 will give me what?
6.
6, right?
6.
Then we'll have plus y is equals to 10. Collect the like terms. What am I going to have? Y is equals to 10 minus 6 because it is closed initially. So I'm going to have y now to be equal to 10 minus 6. That will give us 4.
4.
Therefore, x is equals to 3 and y is equals to 4. That will be our final answer for this. Have you gained
Yes,
anything?
sir.
So this is how to go about it. Now, this one is quite straightforward. It's quite straightforward because the coefficients of y are equal directly. So we solve it without even stressing ourselves. So maybe in the next question we will solve, we'll have something totally different. So because that's my own format, I will ensure I bring different angles that different corners or angles at which the question can actually be given to you. Can I move on?
Yes, sir.
Nima, have you copied?
Yes. Yes.
Okay. Now, this is Khadija Modibo, right?
Sir, please on to go and come back.
Okay. So let's move on to the next question. So this time around, we are required to solve the equation. I think this one is similar to what we did now too. We are required to solve the equation 2x plus y is equals to 7, then x minus y is equals to 1. So these are equation 1. These are equations. So remember, we are focusing on elimination method purely for now. So let's look at what you have in this place. Have you written the question?
Yes, sir.
No. So from the equations that we are seeing in this place, we have 2x plus y equals to 7. We have x minus y is equals to 1. Which one will be very easy for us to eliminate, to remove in this question? X or y?
X.
Okay. Somebody said x. Okay, I think I've not explained that statement, this question I asked initially. Anyone that the coefficient of it are equal is the easiest to eliminate. Anyone whose coefficient is equal is going to be the easiest one to eliminate. Do you understand? If we have anyone being equal there. So which one will be easier for us to eliminate this time around?
Y.
Why? Do you get the point now?
Yes, sir.
Mariam, I can't tell you talking.
Yes, sir.
Yeah. So why would be very easy for us to actually eliminate from what you're doing? Aisha, are you following what you're doing? Are they doing?
Yes, sir.
Jafar, are you following?
Yes, sir.
Can I move on?
Yes, sir. Yes, sir.
So from what you have there now, the first check I asked you to check is whether we have anyone that has the coefficient be equal or not. Of course, in this one, we have one that the coefficient of one of them is equal. Which one is coefficient of them? Whose coefficient is equal in this one?
Y.
Y. Then that is the first check. We have agreed that y coefficient is equal. Step 2, are they having the same sign or different sign?
Different sign.
So if they're having different sign, are we going to add or subtract?
Add.
We are going to add them up. I hope we are all communicating, please.
Yes, sir.
Now, so we add them. If you're adding them up now, focus on x, put plus here so that you remember that we are adding them. Not too close, a bit far at the base, a bit far from x. Now, if you're adding them up now, 2x plus x will give us what?
3x.
That will give us 3x. Then plus y and minus y, we cancel each other because their coefficients are equal, right?
Yes, sir.
And that will be equals to now. Uthman, rather, are you following? Is your network okay now? Can you see my screen now?
No, sir, but I'll try again.
Okay, I don't know what could be the cause. It is network actually.
It's my network.
Yes. You can still try again. You can still log out and log in again, possibly. Or you put your phone in on flight mode, then you what's it called? Remove it from there, then you check again whether it's going to work. So let's move on from what we have.
Okay.
So if you check the second side, we have 7, then we have 1. So since we are adding the equation of 7 plus 1 will give us what? It will give us 8. Am I correct?
Yes, sir.
Then from this now, 3x plus 0 will give us 3x now is equals to 8. Divide here by 3, divide here by 3. 3 and 3 will go, so you have x now to be equals to 8 divided by 3 is what? We don't use decimal under this topic.
8/3.
So now this one can be converted to mixed fraction. How many 3 can I get instead? That will give us 2 whole number, 2/3, right? That will be the value of x. Is that clear enough?
Yes. Yes, sir.
So that is what the value of x. Now the next thing is to substitute or put, just like I said the other time, or let us be mixing language. Substitute x equals to, now look at what I'm going to do here. When you want to substitute, you don't substitute the mixed fraction. You substitute improper fraction instead. Meaning substitute x equals to 8 over 3, not 2 whole number 2 over 3, because that one will cause confusion for you. So substitute x equals to 2 over 3 in equation what? Which equation should we use this time around?
Equation 2.
Equation 2. In equation 2. In equation 2. Equation 2 is x minus y is equals to 1. And we have gotten the value of x here to be equals to 8 over 3. So I'm going to have 8 over 3 minus y is equals to 1. 8 over 3 minus y is equals to 1. Then I want us to look at something here. Two ways actually. If I want to collect the like term, since y is having negative term, so the easiest thing to make work easier for us I can do is going to be take y to the right hand side and take 1 to the left hand side. If I take 1 to the left hand side, I'm going to have 8 over 3 minus 1, because it is plus initially. 8 over 3 minus 1 is equals to, this is minus y from the starting. If you take it to the other side, it's minus, I turn to what? Just ordinary y. Is that still clear, please?
Yes.
Now,
Yes,
so
sir.
then we can now find the LCM and get our result from this one. We can find the LCM and get our result from it. What will be my LCM for this left-hand side?
3.
3. How many 3 can I get in 3?
1. 1.
1 times 8 will give us what? It will give us 8 minus. How many 1 can I get in 3?
3.
That will give us 3, right?
Yes.
3 times 1, that will give us 3. Everything equals to what? Y. So from here, we can now say 8 minus 3 will give us 5 over 3 equals to y.
5.
Right? Therefore, y equals to 5 over 3. Or you have one whole number, 2 over 3. That will be our result here. Can you see the screen now?
Yes, sir.
Uthman. Uthman, can you see the screen now?
I'm going to try through my phone. I can see it now. Yes.
Okay. Alhamdulillah. So don't worry, when we solve the next example, I believe you get it right, inshallah.
Okay, sir.
Tell Adama thank you for allowing you to use that phone.
Okay, sir.
So when we solve the next question, I believe inshallah we'll be able to catch up with what you have done earlier. Have you all copied this? Have you copied this?
Yes.
Now, Mariam, have you copied this? Name your own. When we are solving the next one, we'll copy. Just leave this one for now, since we still have other example to be copied.
Okay.
Madiba, have you copied?
Yes.
Now, so let's move on to the next one, right? Adedoyin, have you copied it?
Yes, sir.
No. Now, we are going to go into another approach now. If you look at the next question that we have in this place, do we have anyone sharing the same coefficients? As in a letter sharing the same coefficients? No. So if we check this one around, this time around now, we don't have a single letter sharing the same coefficients. X and Y, X are not sharing the same coefficients. Y also, they are not sharing the same coefficients. So we can't use that direct method that we did the other time. So we are going to change our approach this time around. So let us call this one equation 1, and let us call this one equation 2. Can I move on?
Yes.
Yes.
No. So now, if you want to solve this one, merely there are one shortest method that we can use, but I want to avoid that. Let me just give us the generic one, the general method that all of us will understand. Which letter you can decide to eliminate any letter of your choice this time around. You can eliminate any letter of your choice this time around. But to me, just always prefer we consider eliminating the second letter, not the first one. The second letter will make the work very easy for you to do that, eliminating the first one. So let's go into this now. So if I want to eliminate y this time around, I will multiply. Are we following this?
Yes.
Multiply equation 1 by coefficient of y in equation 2. What's coefficient of y in equation 2?
3.
Right.
So you multiply equation 1 by 3. Then you multiply equation 2 by coefficient of y in equation 1.
That's 2.
That is multiplied by 2. My first statement, is it clear to everyone, please?
Yes.
Everybody, Nima.
Yes.
Okay, Usman, you are following into right?
Yes, sir.
Now, so multiply equation 1. Multiply equation 1 by coefficient of y in equation 2. That is 3. Then multiply equation 2 by coefficient of y in equation 1. That's the first step. So let us work it out now. If you work it out now, 3 times x will give us what?
3x.
3x.
That will be 3x plus 3 times 2 will give us what? 6y.
6y.
Right? Then equals to 3 times 5 will give us what? 15. Then this is going to be our equation 3 now. Then the second equation now, 2 times 2 will give us what? 4x, right?
4.
Then 2 times 3 will give us what now? 6y.
Y.
Am I communicating, please?
Yes.
Now equals to 2 multiplied by 8 will give us what?
16.
That will give us 16. This is going to be our equation 4. Now, our attention is now going to be shifted to equation 3 and 4 alone. Check equation 3 and 4. Is
You
there
wrote
anything you can-
elimination method on top.
You said?
You wrote elimination method on top.
Yeah, that's what we are doing. We are not doing substitution yet. Do you get? Elimination method is we want one letter to be cancelled out. So once a letter has been cancelled out, we have eliminated it. And that is why we call it elimination method. So we want to eliminate y this time around now. Do you get that?
Yes, sir.
So if it's substitution method from step 1, you first make something the subject of the formula, then you now substitute. That's why they call it substitution. But for elimination method, we first find the means of eliminating one letter before we keep on solving. Can I move on?
Yes.
Now, from what you have, and I'll check equation 3 and 4. Is there anything that we can eliminate there now? Everybody?
Yes.
Yes.
Uthman. No. So which one can we eliminate from this?
6y and 6y.
6y and xy. Now, since you have identified that there's something we can eliminate there, what was the rule that I gave to you? If they're having the same sign, what are we going to do?
Minus.
Subtract.
Minus. So you are going to put minus at this corner here now. Because if you check 6y and 6y, they are having plus plus, so you subtract. But you have to be very careful about something at this stage. You have to be very careful about something at this stage. If you are doing 4x minus 3y, at the other side, you must use 16 minus 15. If you are going from bottom to top, you must go from bottom to top throughout. So that you not do 3x minus 4x at one side, they are not going to do 16 minus 15 at the other side. That would be very wrong. If you are going from bottom to top, you must go from bottom to top for the second side. You must follow the same pattern throughout. These are the common mistakes that students usually make at this stage. Can I move on?
Yes.
Yes.
So at this stage now, our next step or next approach in this case is going to be what now? We are subtracting, just like I said earlier. When we are subtracting, we are going from bottom to top. That is 4x minus 3x. If you know you're going to get confused, you can put it somewhere in your notes. You can write 4x minus 3x. 4x minus 3x will give us what?
X.
X.
That will give us x. Then, because this one we are subtracting, you don't need to waste your time for this one. 6y minus 6y will give us what? 0. Do you get?
Yes.
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 We have eliminated y now. Let us go to the second side. The second side, am I going to do 15 minus 16 or 16 minus 15?
16 minus.
And that will give us what? 1. So we can simply say now that x is equals to 1. We have gotten a value of x. Then we'll repeat the step we have done in the previous two questions that we solved. So, and that's going to be what now? Substitute. Don't forget, that's why I don't want to be using substitute. Put the fact that we're using substitute, that doesn't mean we are dealing with substitution method. So you can put x equals to 1 in equation. Which equation should we substitute into?
Equation 3.
Equation 3. A very good idea. However, equation 1 and 2 are very small compared to 3 and 4. So it is better we use equation 1 or 2. If you use 3, you still have the same result. We still have the same result. But we always prefer that whenever you want to substitute the original equation, meaning equation 1 or 2. Do you get?
Let's do
Yes.
equation 1.
Okay, equation 1. So if you substitute equation 1 now, our equation 1, first write the equation 1 down. That's going to be x plus 2y is equals to 5. What is value of our x in this equation?
1.
So I'm going to have 1 plus 2y is equals to 5, right?
Yes.
Collect the like time now. This is positive 1. Take it to the other
Yes.
side. That will give us 2y is equals to 5 minus 1. So I'm going to have 2y to be equals to 5 minus 1 will give us what? 4, right?
4. Yes.
Divided by 2,
Yes.
divided also by 2. 2 and 2 will cancel each other. So I'm going to have y now to be equals to what is 4 divided by 2?
2.
That will give us. So we are done. We can now say therefore x is equals to 1 and y is equals to 2. Shikena. So copy it quickly. Is that clear enough?
Yes.
Yes.
Can I move on to the next question?
Yes.
Yes.
So let's check this one out. Or should we solve this or this? Okay, let's solve this one. We have two questions more to be done, or 3 questions more to be done. Then elimination method, we are not coming back to it again. So let's check this one out. So which one should we eliminate this time around? X or Y? Is there anyone that we can eliminate directly based on the rule I gave to you?
No.
No, none of them is having equal coefficients. So we follow our normal approach. This is our equation 1. This is our equation 2. So which one should we eliminate? X or Y?
Y.
Y. So if you are eliminating Y, are we all following, please? Everybody, are we all following?
Yes.
No. So equation 1, what am I going to do then? I will multiply equation 1 by what?
By 1.
1.
By 1. And I'll multiply equation 2 by what?
3.
3.
By 3. Uthman, are you following, please?
Yes.
Because I noticed your screen was not showing when I did this the other time. Now let's move on. So from what I'm having here, multiply equation 1 by 1. 1 times 4x will give me 4x. 1 times 3y will give me what? Will give me 3y. And 1 times 0 will give me 0. This is going to be my equation 3. Is that correct?
Yes.
Then let us go for the second equation now. 3 times 2, that will give me 6x. Then 3 times y, that will give me minus 3y, equals to 3 times 5, that will give me 15. So this is going to be my equation 4. Is that clear enough?
Yes.
Yes.
Now, so let us move on to the next stage now. From the next stage that we are having here, am I going to add or subtract?
Add.
Add. Why?
Because they are the equations are different.
Because we got the sign are different. You understand? The sign for those ones that the coefficients are equal are different. This one is plus, one is minus. If you don't understand, don't just follow crowds. You're always free to call my attention. I will explain if you don't get the point, please. So let's move on. So since you say we are going to add now, put addition here. Put addition to this side. What's going on now? Nima, you are disturbing my screen. So from what we have here now, 4x plus 6x will give us what?
10.
10x.
10x.
Then, of course, this one, what will happen to it? They will cancel each other, right? You don't need to give yourself a dick over that. They are going to cancel each other. That's going to be plus 0, right? Equals to 0 plus 15. That will give us what? 15. So I'm going to have 10x now to be equals to 15. Divide a by 10, divide a by 10. 10 and 10 we go. So I'm going to have the value of x now to be equals to, how many 5 can I get in 10? That would be 2. 5 and 15, that's going to be 3. and that will give us 3 over 2, which can be simplified into one whole number, 1 over 2. Is this clear to an extent?
Yes.
Yes.
Can I move on to the next stage?
Sir, please, but
Yes.
can you
Yes.
keep your answer at the improper fraction?
No, it is always preferred to solve it to the lowest level, that is mixed fraction.
Okay.
Then, if you are done with that, if you want to substitute now, it is not advisable you use mixed fraction. You go and substitute improper fraction. If not, it will make your work very complicated. Am I good to go?
Yes.
Yes.
So let's move on. So now substitute x now, or put x, just like I said the other time, put x equals to 3 over 2 in equation. Which equation should we use? 1 or 2?
Mm, 2.
2.
Okay, 2. Okay. In equation 2. So you put into equation 2. Our equation 2 is what? 2x minus y equals to 5, right? I can have 2 open brackets, 3 over 2, close the bracket, minus y equals to 5. Now, depend on what you want to do here. First approach, you can say 2 and 2 will cancel each other. You are going to be left with 3. Or I want us to learn something here again. If you are multiplying fraction by a whole number in bracket like this, the number will only affect the numerator. Do you get? So this is going to be 2 times 6, 2 times 3 rather. That will give us 6. For the purpose of those that will, for the purpose of learning, that will give us 6 over 2. You will not say 2 times 3, then 2 times 2. That will be wrong. Do you get that?
Yes.
Then we have minus y equals to 5. I was supposed to do it directly to say 2 here, 1, 2 here. That will give me 1 as well, and we put 3. But for the sake of learning, that's why I just show you the. So 2 here will give me 1 now. 2 in 6 will give me what? 3. So I have 3 minus y is equals to 5. So just like we did in one of the previous questions that we have done, your next step is supposed to be what now? Since y is having negative sign, take y to this side so that we can change the negative sign to positive, then move 5 to the left-hand side. And that will simply give us 3 minus 5 is equals to, this is minus y initially, take it to the other side, turn to ordinary y. Do you get that?
Yes.
Yes.
3 minus 5 will give us what now? Y equals to minus 2. So we can conclude now that therefore x is equals to 3 over 2 and y is equals to minus 2. And that is how to solve this particular problem. Is it clear to an extent?
Yes.
Now, have we all copied this?
Yes.
No.
Okay, once you're done, let me know, please.
I'm done.
Okay, let's move on. Now let's look at a question like this. How do we solve a question like this?
The last slide, some seconds, please.
Okay, no problem.
We can move on. We can move on.
Okay. Okay. Now, if you look at this question, this one is looking totally different from what you have done earlier. And this is format of simultaneous equation as your NSS2. You should make it advance a little. So how do we solve a question like this? We have 2x plus y is equals to x plus 3y equals to 5. Since the method we just approach, the method we adopt here is this. It's just like saying A is equals to B is equals to C. So what we do in this type of question is that you pick them, make them pair. Meaning you can simply say A equals to B. You will simplify it to form equation 1. Then you do A equals to C. You simplify it, you call it equation 2. Or you can say A equals to B. Then you say B equals to C. You'll still get your answer right to form your equations. Do you get the point, please?
Yes.
Yeah.
Now, let us apply it here now. If you look at it now, this one represents A, this represents B, and this represents C. So if I want to solve the equation now, my step is going to be 1, from the equation I've been given above here, this is the same thing as 2x plus y equals to the last number equals to 5. Call this one equation 1. Did you get?
Yes.
Yes.
Then you pick the one at the middle too. That's going to be x plus 3y is equals to what? 5. Call this one equation 2. Am I communicating, please?
Yes.
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 So this is what we have in this place. Now, can I move on?
Yes.
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 So from what you have in this place now, is there anyone that we can eliminate directly there?
Yes.
Which one?
No.
Is there anyone you can eliminate directly?
No.
No, there's none. Because none of them is having equal coefficient, so we cannot do the elimination directly. So what step am I going to do this time around? Now we follow our proper step. That is multiply this equation by 3 if I'm eliminating y. Multiply this equation by 1. Then we solve everything up to the end. Is that clear enough, please?
Yes.
Now.
Yes.
So this one I won't solve it further because I believe you know how to solve it. So leave space in your note and complete it yourself. The only thing I want us to understand here is the process. You said what?
Is this still elimination method?
Yes, still elimination method. Still elimination method. So it's still the same procedure we are going to use, so I don't want us to stress ourselves over that. Have you copied this?
Yes.
Others?
Yes.
No.
Yes.
Yes.
No. So please don't forget what I asked you to do. What I asked you to do about this one. Complete this. The only thing I want us to learn from this equation is that you can see equation that will be very long like this. You just split it into 2, then you simplify, then use the elimination method to solve it. Let us look. Can I move on to the next one now?
Yes.
So let us
Yes.
check this one now. What of something like this? I think this one is still the same method. It's still the same method. I don't want this one is too simple. Can I move on?
Yes.
No. Now let us look at this. This is one I'm looking for. This is one I'm looking for. So let's check this one out. The only thing I will do here also is that we'll form equation will be the one to go and complete it. If you have mastered the one that we are going to do, I'm going to give us 5 questions to solve as an assignment, and I'm expecting the submission to be early in the morning tomorrow. Would it make any sense? I'm expecting in the evening today, since you're having the class by 11. I'm expecting it in the evening today, please, so that we'll know whether we've actually mastered what you have done or not before we go into elimination method. Can I move on?
Yes.
Yes.
Now, solution to this. If I want to solve this particular question, follow the same approach as what you did earlier. The first step is going to be pick the first letter and equate it to the last one or the second one, anyone you prefer. If I'm equating the first one to the last one, I'm going to have what? 3x minus y is equals to 5x plus 4y. Do you agree with that?
Yes.
Then the next step is going to be collect the like terms. Move everything to the left-hand side so that we equate everything to 0 or any number that's available. So this is going to be 3x. This is plus 5x initially, right? If you take it to the other side, what are you going to have?
Minus 5x.
Minus 5x. Then we have minus y. Take 4y to the other side. What am I going to have? Minus 4y. Everything is equal to 0.
That's equation 1.
We are not done yet. We'll simplify it until we have those two terms. Is everybody following, please? Mariam?
Yes, sir.
Now, Khadija?
Please, can you repeat yourself again?
Okay. Can I repeat the statement you meant, right?
Yes.
No. So what I said basically is that pick the first expression here, equate it to the last one. I want us to agree on one method so that you don't get confused when you get back to school. Pick the first one, equate it to the last one. The first one is 3x minus y. That's what I'm having here. Equals to the last one, 5x plus 4y. This is what I'm having here. Then the next one is to collect the like terms. To collect the like terms, let's look at it again. To collect the like term from what you have there, that's going to be, we have 3x, right? This is plus 5y initially. If you move it to the other side, that will turn to plus 5x initially, rather. That will turn to minus 5x. Is that step clear?
Yes.
Yes.
Then the next one is minus y is here already. I will put it down. Then take my plus 5y to the other side. That will turn to minus plus 4y to the other side. That will turn to minus 4y. Everything equals to 0 because I've moved two of them from this right hand side. That's why we have 0 there. Is that clear enough?
Yes.
Now, so from
Yes.
what I'm having in this place now, though all my answer, I think all my answer will be equals to 0 based on what I'm thinking. I think all my answer will be equals to 0. However, just understand the process. So from what I'm having here, 3x minus 5x will give us what?
Minus 2y minus 2x.
That will give us minus 2x. Then minus y minus 4y will give us what?
Minus 5.
Thank you so much for that. I was expecting error on that. That will give us minus 5y. Everything is equals to 0. Now, I like doing something at this stage. I don't like seeing negative time at the beginning of my solving. And if you give you a question like that, you can adopt the method I'm going to do now. So what we do is that multiply true by minus 1. Multiply each term by minus 1. If you multiply true, you can write it in your statement, multiply true by minus 1. That will always ease the work for you when you are solving. If I multiply true by minus 1, minus 1 times 2 times minus 2 will give me just 2x, right?
Yes.
Then minus 1 times minus 5y, that will give me plus 5y. Then minus 1 times 0 will give me 0. This is going to be our equation 1 now. Is that clear enough, please?
Yes.
And let's move on to the next one. The next one will pick the middle term and equate it to the last one. Is that taken? Also, that's going to be x plus 2y equals to 5x plus 4y. Do you get that?
Yes.
Collect the like terms as well, just like we did in the previous one. That will simply be x minus 5x, because this is plus initially. If you move it to this side, turn to minus 5x. Then we have plus 2y. Move this one to the other side again. That will be minus 4y. Everything is equals to 0. Is this step clear to us, please?
Yes.
Then from what I'm having here, x minus 5x will give us what? Minus 4x. 2y plus 2y minus 4y will give us minus 2y. Then everything equals to 0. Is that clear enough?
That plus 2y minus 4y.
Yes, plus 2y minus 4y will give us minus 2y.
Sir,
Now,
sorry, can you explain again from that 2x plus 5y equals 0 equation 1?
okay, 2x. I don't get. Okay,
From
2x
where
plus
we
5y equals to 0. Okay. You know, everything is minus. I'm having minus 2x minus 5y equals to 0, right? That one is clear.
Yes.
Now, what I said is that I dislike seeing minus at the beginning of my equation. So to remove that minus I'm having at the beginning of this equation, at the beginning of minus 2a, what you can do is that you multiply each of the term by minus 1.
Yes.
So if you multiply each of the term by minus 1 times minus 2x will give me plus 2x, right?
Yes.
Then minus 1 times minus 5y will give me what? Plus 5y, right?
Yes.
Then equals to minus 1 times 0 will give us what? 0. Is that clear enough?
Yes.
Then you go to the second one. Then let's go to the second one. The second one, you follow the same approach. I believe you can understand the step we took for that one too, right?
Yes.
So what
Yes.
we're going to do next is going to be what now? Multiply true
True by minus 1.
by minus 1. So if you multiply true by minus 1, multiply true by minus 1. What am I going to have? Minus 1 times 4 is give me what?
4x.
That will give me 4x plus 2y equals to 0. Then there's a number that can even divide everything through in this place. What number can divide everything through?
2.
2.
So we have divide a by 2, divided by 2, divided by 2. So I'm going to have this place to be 2x now plus 2y plus y rather is equals to what? Is equals to 0. Is that taken?
Yes.
So
Yes.
and that's going to be my equation what now? That will be my equation 2. Do you get?
Yes.
So this is kind of question they can give you in theory that you must actually understand the step. Then from this now, since we have gotten equation 1 and 2, to now make life easy, I will now combine the two equations together. You understand? Combine the two equations. What is our equation 1? 2x
2x
plus
plus
5y is equals to what? 0. Right? This is our equation 1. Then the
Yes.
second equation is 2x plus y is
Plus-
equal to 0. This is our equation 2. Then from then, I believe you know the step to do. You can eliminate what you can eliminate there, then you get the value of x and y.
Okay, sir.
Do you understand? The main thing I want us to understand from this, my long explanation, is how to convert this kind of equation to simultaneous equation. That is the most important part. And it's very important that you take note of that. Is that clear?
Yes.
Yes.
Now, so this is 10:09 or 10:10 already. So we are going to end the class at this level for mathematics. So I will give you, is there anything for us to add?
So now, sir, we are supposed to finish the 2 questions.
Yes, you now solve the 2 equations now.
Then send it to the
Simultaneous.
class.
Yes,
Okay.
you eliminate x. Since the coefficient of x are equal here, you can eliminate x. So you're going to have, and you subtract 5y minus 5y. So you have the value of y to be equal to 0. Then you solve the remaining one to get the value, substitute to get the value of x.
Okay.
So the main thing is how to convert question like this to simultaneous equation. That's what I want us to actually learn there. Have you gained anything, please? Everybody?
Yes.
Yes, sir.
Okay, alhamdulillah. So we'll take a break now before we return back to physics. You cannot jump from physics, from math to physics directly like that. So in the next 10 minutes, we'll converge back, inshallah.
Okay.